Building the perfect home office is something that takes a lot of time and planning. And I've always wanted a space where I can be at my most productive, have all the tools that I need ready at hand, but also be comfortable so that I can relax at the same time. So I don't know, every time I move, it feels like I'm in a rush to get things into places, and I just end up throwing things like my desk in the first spot that makes sense so I can get it over with quickly, rather than really thinking ahead to how I'm gonna use the space effectively. So there seems to be a disconnect between where my things end up and what would be the most effective use of the space. Now, if you look back at all of my past videos, you'll see a lot of different backgrounds, and that's because I move a lot. And for once in my life, I am trying to stay in this space as long as possible. So I decided that now would be the best time to commit to making the most effective space for my needs. In order to make this home office the best it can be, I wanted to be able to work from home as an embedded hardware engineer, design and build cool projects for this YouTube channel, but also be comfortable being at this space all day long so that I can still play some video games here and feel energized even after a long day of work. As I check off those requirements, I'm also going to be showing you how I designed all of the custom lights in this room so that you can take those ideas and apply them to your own space. And I will also be showing off the open source software that runs my LED wall here because I got a lot of questions about it in my last video. Let's get started. You can't have the perfect home office without the perfect desk. And for that, this video's sponsor, FlexiSpot, has you covered. In addition to improving my posture, I've also noticed that standing regularly while I work improves my focus and leaves me feeling more energized throughout the day. This is the FlexiSpot E7L Pro Standing Desk. It features one-touch height adjustment with 4 programmable settings and 3 powerful motors with a lifting capacity of 330 pounds. Even with all this stuff on here, it can still lift me without a hitch. I love that I can fit my chair completely under the desk to free up floor space for an air mattress, and even at max height, there's barely any wobble. The assembly was pretty straightforward. The instructions say a drill is optional, but you'd need some pretty beefy wrist muscles to do this whole thing with a screwdriver. At one point, I was struggling to find the holes, and I realized I had the desktop backwards. The L can be assembled on either side, so it will always perfectly fit your space. It is worth noting, though, that the motors are extremely heavy, so I would recommend getting help when assembling or moving the desk, unlike I did. Overall, the FlexiSpot E7L is an amazing standing desk, and this is actually the 3rd desk from FlexiSpot I've used. The E2 is great if you're on a budget, and I've also used the E5, which is the perfect mid-range standing desk that has amazing stability for the price. The E7L starts at $610, but if you use my coupon code down in the description, you can get $30 off any of the desks in the E7 lineup, including the Pro and the E7L that I have here. It is an absolutely incredible deal. I encourage you guys to check it out, and thanks to FlexiSpot for sponsoring this video. Okay, let's talk lighting. Backlighting is a super cheap and easy way to add some vibrance to your space, and using addressable LEDs allows you to customize that feeling even further. I'm a huge fan of open source software, so in order to get this effect, I'm using a free platform called WLED. All right, so this is the star of the show, these BTF lighting LED strips. I use these in pretty much all of my projects, so we're gonna use them again today. Comes with this little connector, which we need. We also need this guy, and this is an ESP8266. I buy them in bulk to get them as cheap as possible. They're about $3 a piece. We also are gonna need something to power this, so I got power supply. This one is 5 volts, 3 amps. That should be plenty. Put LEDs wherever we want to, and it came with all these tips. We're just gonna use this one right here, which lets us screw our own little things in, and this should be all we need. So the end of the LED strip has this little connector here, which plugs into this guy. Boom. We're gonna take these 2 extra power cables, connect them to our power supply thing, and then we're gonna take these cables, connect them to our controller. Boom. And then when we plug this in, it'll power the LEDs, it'll power the controller, and everything will be fantastic. All right, I've plugged my ESP8266 with a cable attached into my computer, and now I'm running a tool called ESP Home Flasher. I'll have a link to all of this down in the description, but as you can see, I'm connected to the serial port, and then I have WLED 12.0, the ESP8266 version. All I'm gonna do is click Flash ESP, and this guy's gonna start blinking. There we go, and it's programming, and it is done. All right, so now we just have to connect this guy and enter the Wi-Fi Wi-Fi credentials. All right, here on my device, I can see WLED AP listed as a Wi-Fi network. Now, I'm recording with my phone, but you can do this on your phone, and it's pretty much the same. This will open up, and you can go in here and input your Wi-Fi SSID and password, and then change any other settings you want to. You can set a web address, change the name of the device, and whatnot. And when you click Save and Connect, you can then connect back to your Wi-Fi network, and you will be able to control your lights from whatever device you're on. So I'm going to set this up. Obviously, I don't want to dox myself, and we'll jump back into it. To the device using the address that I typed in on the previous screen, just here in my web browser. And you can do this on your phone too. There's actually a WLED app that has the same interface, makes it super easy. I highly recommend it. But as far as this goes, we're going to go over to config and LED preferences. Now, I can go up to 3,000 milliamps, which is 3 amps, because that's what my power supply has. Total LED count, I don't know, let's say 150. I actually don't know how many LEDs this is going to be yet. I just want to see if this works. 5 volts, all this stuff is fine. Pin 2 is correct for what I did. If you're doing this the same, on the Wemos D1 Mini here, D4, well, it's upside down, but D4 is actually pin 2. That's a little confusing, but it's correct here. And then I think the rest of the stuff we can just leave as the default. And click Save, and we're back here. And now I guess it's time to just plug in the LEDs, and we'll see what happens. All right, here we are. I'm gonna plug it in, and everything will light up orange. That's the default color. But if I go back in my app, I can change this whatever I want. Say I want some green, and just click a button and it's green. And the cool thing is this has a ton of effects. Like, let's say I want to do like a breathing effect. Yeah, that's pretty sick. Here, I'll turn this over here so you can see what I'm seeing. Lots of effects, like literally hundreds. Let's pick a good one. Let's do a fire color palette. Boom. Yeah, that's sick. So what we're gonna do now is put these LEDs on the desk around the edge, and we'll see what that looks like. The other cool thing about these LEDs is that they have this adhesive backing. So try to pull off this blue part without pulling off the adhesive, but this is sticky, so I don't have to do anything crazy. Just peel this blue off and stick it wherever I want it to go. So let's do that. And there we have it, some backlighting. Man, my desk's kind of a mess, and I still have to do the cable management, but the lighting is sick. All right, here we are, my desk. And I even added some to my partner's desk, and it looks great. Woo, it's a party in here now, let's go. For the Lego shelf, I'm gonna use the same software, but the hardware is gonna be a little different. I have 5 shelves that I wanna light up, but I want them all to be synchronized with each other. So I'm gonna use one microcontroller and have the data line split 5 ways to write the same data to each of the strips. This setup uses a long data cable, and in the past, I've experienced flickering lights or other issues. The ESP8266 and most other microcontrollers only output 3.3 volts, and these are 5 volt LEDs. For a short data cable, this doesn't really matter, but longer cables can cause a voltage drop. If you have this issue, I would recommend using a 3.3 to 5 volt level shifter, but lucky for me, I was able to skip this step. After connecting each strip, I'm making sure everything still works so I can make adjustments to the hardware before it goes permanently on the shelf. And now that everything's working, I can stick the strips to the back of each shelf. And just like that, the shelf is lit. I have this little bag here where I put my ESP8266, and then my main power and data wires are zip tied along the side here, and then LEDs run behind the shelves. This shelf is actually supposed to sit flat against the wall, but I 3D printed some spacers up here where it screws in so that it sticks out about 1/2 inch and there's room for the LEDs. If you don't want to do backlighting like this, you could totally mount the LEDs like on the front here or even on the bottom, but I would recommend getting an LED diffusing channel if you're going to do something like that. So I'll leave a link down in the description if you want to check those out. So now you know a super easy way that you can add custom lighting to your room that not only looks great, but can also be accessed and controlled by any device on your network. But WLED isn't just for LED strips. You can actually use it to control an LED matrix as well. A few years ago, I showed you guys how I built a massive LED wall on a budget. This thing is literally made out of cardboard and these light strips that I used on the desk. But you can actually build this even cheaper than it was back then. I think you could probably build this entire panel for less than 50 bucks if you really do it right. And to me, that's insane. But let's flash WLED on this thing and see what it can do. Just like last time, we can flash our microcontroller with WLED, but here we can go into this 2D configuration and configure it to be a matrix using a serpentine pattern. You can control where the first LED is. For me, it's on the top left, and a horizontal orientation. My dimensions are 36 by 16, which gives me 576 total LEDs. Now, it'll give you a little demo right here of what your matrix is going to look like, but that's pretty much it. Once that's set up, then your thing's going to restart, and you can go into the effects and sort by matrix effects here, and now you have all of these matrix effects. So I'll just show you a couple of my favorites. Just to start, this is what a regular 2D animation would look like on a matrix panel like this. This is the rainbow pattern, the same one that my bookshelf over here is doing. All right, it looks a little different on the matrix, but I think it still looks cool. So here are some 2D specific effects. This is the black hole. Takes a second to clear out the old one, but this looks really cool. It just has a bunch of rings spinning around a center there. And the colors are fully customizable. Let's see, this is the DNA effect. I really like this one too. Looks really cool. Obviously, the ESP8266 isn't a super powerful microcontroller. If you were to use an ESP32, you'd get a bit of a higher frame rate with these same animations. But I do think that this looks really cool. And then the last one I want to show off is this octopus effect. I thought it'd be cool to set this to like an underwater theme, because ultimately this is going to go up on my ceiling. And so I thought this would be cool to make it feel like you're kind of underwater. As you can see, I ran an extension cord up to my ceiling so I can use this as an overhead light for my desk. It allows me to set the mood when I need to focus, or put on a cool animation when I want to just kick back and relax in here with the vibe. I am really happy with how using WLED on these panels turned out. If you want to see how I built this panel and how I actually used it for an LED wall like this one originally, you can check out the video in the card up here. I'd also love to hear your guys' thoughts on WLED running on this matrix. I have 3 more in addition to the one that's already up there. So what do you think? Should I put the rest of them on the ceiling too? Or should I use them for some other purpose that I haven't thought of? Let me know, and while you're down there, be sure to subscribe and leave a like on the video so YouTube knows that you like what I'm doing here and you want to see more. As promised, I'm going to talk about the free software I use to run animations on this LED wall. But first, I want to give you guys a tour of my desk so you can understand why this change was so important to me and how I actually use this space every day. Starting with the split keyboard, I know it is kind of nerdy, but I think it's really comfortable to type on. This is the knock-free light. I love the LEDs in it. There's a bunch of different animations and you can customize the colors and the macro keys. I actually have a full review and I'll link it in a card up here if you're interested in this keyboard. I have a second one that I keep in the office so that I don't have to adjust to 2 different keyboards, so I can just use the split keyboard everywhere I go. Up here, this is actually a small touch screen that was meant for a Raspberry Pi, but I just have it sitting here. Plug in HDMI, plug in USB, and the touch screen works as you'd expect. It works great with Windows, and I just keep a bunch of little shortcuts on here so that no matter what I'm doing on my main screen, I just have quick access and I can launch an application without having to take away from whatever I'm doing on my main screens. I like a vertical monitor because I write a lot of code, and code is typically a lot of very short lines, so vertical monitors are really good for that. And then obviously this is the monitor that gets mirrored up onto the LED wall. So I do like my ultra wide, but I can't mirror the ultra wide onto this aspect ratio, so I have to keep a standard aspect ratio as my main display. But let me know, do you guys think this is too much screen? I kind of like it. Lots of real estate. Down here, this is the home server I built in the last video. This just lets me monitor activity, CPU usage, not a lot going on right now, nothing being downloaded, and our temperatures are constant, so that is looking pretty good. If you want to know more about what this home server does, check out my last video in the card up here. A couple of desk organizers, and then here, this is all of my electronics equipment. These drawers just have all kinds of random components in them. Some solar panels from years ago, some motors. Yeah, you you get the idea. It's microcontrollers. Just all of the random project parts that I've collected over the years go in here. I actually know pretty well where most of the things are. If I ever need to grab something, like I keep my pliers and other soldering tools in here right under the solder. So pretty nice to have everything organized into drawers. Before I got these, all of this stuff was literally just thrown into a bag and it was an absolute mess. Down here I have my little soldering station. This used to sit in a drawer before I got this L-shaped desk. So having this extra space to expand has been really nice because now I can just have my soldering iron out. Easy access if I want to try and build something. And this is my pride and joy. It is a really old Tektronix MDO 3000 oscilloscope, and this thing has some issues. It's actually like pre-production, outdated firmware. It's not calibrated. This leg doesn't actually sit on the ground because it's broken. But man, I got a great deal on this thing, and I absolutely love just being able to hook it up to a circuit and visualize the electricity on there. I actually keep the probes underneath it all wrapped up and tucked away, and just overall really happy with how all of this fits. And you know, my PC can fit on the desk too, and there's so much room for the cat. Not a single cable in sight. Well, I guess you can see the power cable running up to the desk there, but man, I am really happy with how this whole setup turned out. Very excited. All right, let's get into this LED wall. So a couple videos ago, I showed you how I built this thing, and that video kind of blew up. I got a lot of comments asking to explain the actual software side of it because I didn't really go into that in that video, but I do think since we're talking about LEDs here, it kind of makes sense to cover this as well. So here is what I'm using. This is called LED Matrix Control Software HD. Kind of a mouthful. I didn't name it, but we'll call it LMCS-HD for short. Also not much better, but it'll have to do. So basically what this software does is it takes a screenshot of whatever my main display is. It only does my main display. I can't pick which display it is. It has to be display 1 in Windows. And it takes a screenshot and then runs an interpolation on that screenshot to convert it into an array of RGB values. You can see there's actually a few different algorithms you can use. The nearest neighbor one looks a bit more blocky. You know, these high quality ones kind of blur the pixels together. So from a distance it looks really good. But you can just stop the capture and it freezes even though my screen is still going. And then start capture again and there it goes. And it's obviously copying it onto the screen. And here is the actual Arduino code that I wrote. I'm not going to bore you guys with the details. Basically I just use this Neo Matrix library to take this array of pixels that just comes as scan lines and actually map it to these individual tiles that you can see here. So that's what the code is doing. Here we get the data, we read all the data in, and we actually write the extra data out. We set the header and then write all this extra data out because we only draw one frame. This bottom panel gets all of the data for this column. And so it gets all that data, passes the data on. This guy gets the data for those two panels, passes it up to the top, and then once all the data has been passed, then they draw their actual frame to the display. And so that's happening across all of here. What you'll kind of notice though is this is only a third of the display, and down here I'm actually running 3 instances of this software. So yes, I have 3 connections over USB serial. Each of these bottom panels has its own USB connection and it's feeding the panels above it. So that's how I'm able to get a pretty good frame rate here. One of the big changes that I've made to the code since I released that video, and I am going to be adding these to my GitHub repo, is now it supports 8-bit data as well as 16-bit data. So I'll show you what that looks like. If I come up here and change the color mode, it's currently in 8-bit RGB, but if I change it to 16-bit, you can kind of see, oh, we get a bit more color up there now. It's not crazy, but we'll go back to 8-bit now, and you'll see a lot of that blue just kind of fades to black. So it's a bit of a trade-off because 16-bit data, you don't get as good of a frame rate. I'm still in 8-bit mode here just because it looks so much smoother compared to 16-bit. 16-bit can get kind of choppy, but depending on what I'm actually showing on the screen, a lot of time you kind of need the 16-bit color because I've noticed that everything in 8-bit color comes out a little more green than I want it to look. So that's just something I've noticed. A few other features, you can actually do microphone capture here. So it's using the microphone on my desk now, and it's displaying the audio all the way up on the screen, which I think is really cool. And with the 8-bit processing, it actually looks pretty close to real time. So that's just a fun little side thing you can do. There's also, you can do images and GIFs. Because of the way that I'm obviously drawing this one display at a time, it would be really hard to synchronize a GIF across all three of them. So for the most part, I just stick with the screen recording, and the screen itself handles the synchronization. So I don't have to worry too much about it. But if you have any questions about this whole setup and how it works, let me know down in the comments below. A few keen-eyed of you might notice that when I redid my whole setup, this wall was actually bigger in that video. It had a 4th column and then a 4th row. Obviously, you wouldn't be able to see the 4th row behind these monitors, so I decided I was just going to shrink it down. I picked the 9 best panels of the bunch and stuck them together to make this one. The frame rate is also a lot better, and I couldn't even do 16-bit on the full-size wall, so having the flexibility with this one is actually really nice. But yeah, let me know what you think. So there you have it. That's how I built the ultimate home office. It's ergonomic, so I can be comfortable while I'm working during the day and still have energy to play games at night. It's functional, so whenever I'm building something, all of the tools I need are right at my fingertips. And most importantly, it looks awesome, so whenever I have people over, I can host them in here. If you made it this far, then you'll definitely want to check out my last video where I built the perfect home server for beginners. I'll leave a link to that right there for you to check out. And huge thank you to FlexiSpot for sponsoring this video. Like I said, I've been using their desks for years, and they seriously have the perfect desk for every budget. Use my link down in the description and get that coupon code for $30 off. And I will see you guys in the next one.